Okay, so it's important to note what we're going through in this process is obviously to be able to analyze this as a truss. So each element can be considered a single unit for node analysis. And so this bottom line here is really just not very important or useful to us because it's continuous. It doesn't understand there's any nodes. So if I highlight this line turns blue. And what I'll do for the sake of this next step is to actually make it disappear. But we know we have all the points. Now our job is just to get each one of these connected to each other. And we could do that just by trying to identify the numbers and connecting a line. But really what we want to do is get into the mode of being able to map these lists together with each other. So we're going to start that. What we really want to do is just take one list and take the first item in the list and match it with the second item in the list, the second item in the list and match it with the third, and then just keep creating lines coming off of that. And so let's go to list, because they're a very important part of the way you work with geometry. And what we want to do is modify those lists, and we want to drop every X item. So I'm going to call that up on, because I want a list, and every other item I want to dismiss, and I want to maybe start with an offset or not start with an offset, depending on whether it's the first or the second element in it. So I'm going to go ahead and copy this over. And then we need to feed in the source of the list. And the list is really all of those points that define the bottom line. And we've already made a list of those points, and we've done it, I believe it's here. 7 points. I don't know why they're not highlighting here. Let's see what these are connected to. So that's our list of points. So let's go ahead and take the flattened version of that out, and we'll put that into the code block. And we'll put that in, and it's the same list, so we'll put it into the other code block. All we're trying to do is pull out all of the points that are one offset from the other. Now, in order to make this work, we need to have some numbers in there. So I'm going to make a code block that gives us the kind of numbers that we need, so we don't have to keep typing them over. And just a simple way to, we need a 2 because we're going to do every other one. We need a 0 as a start point sometime, or excuse me, we'll need a 1. Doesn't really matter which order you type these in, but I should be in some kind of sensical order here. And a 0. All right, so, and I make a little correction there. And let me just zoom in here a little bit. So the way we're going to start with this is that we're going to want every second item of each list. And we're going to want to do an offset that's different for each list, 1 and 0. So we're going to take either the first number or offset at 1 and take start with the second number and do every other number. So now we come up with 2 lists. And this list makes a little bit too many. So we want to, we're going to use a list rest of items. Let's see if I can. And that removes the first item. That's because we do, we're already having to jump over 1 unit. So I'm going to feed that into here, and this now should give us a list of 3 points. So now we have everything we need. We have 2 lists of 3. 2 lists of 3. That's too short. I'll figure out what's wrong there in a second. No, 2 lists of 3. That's probably, well, let me see what happens. So we'll do line by start and end point. And we'll feed this list in to here. And we get our 1, 2, 3 lines. But we have this other list that can be now endpoint and start point, just the opposite way around. So I'm just going to copy this over. And we're going to just, we want to wire it differently. So we want this to be an endpoint and this to be a start point. I said that wrong probably. And we still want this to be a start point. Oh, I know, we want the original list to be the endpoint. I'm sorry. There we go. So let's just highlight these. So those are those three. And then we have the next one, which is the other three. All right, so that is undoubtedly very confusing. It took me a long time to even figure out how to do this. And I probably didn't describe it very well because I tend to have to rethink through it every time also. But this actually could just be reduced down. Once you have mastered the idea of how this actually works, they're all working from a list of inputs. This could actually be reduced down to one functional node. And I'll gather this up. And I'll just show you, it's just kind of one of these opportunities here. This could be renamed as a node. And everything would then be encapsulated. I'll pick that up later. Let's just bring this all together, because this really gets us kind of off track if I go into that too much. I'm going to create a group again, and we're going to call this the bottom chord segment. Now I'm going to just copy that, and we're going to do the same thing for the top chord segments. We're just going to feed it with other data. And so what we want to do is turn off our NURBS line, our NURBS curve on the top. So we're back to that idea of not seeing that whole continuous line. And we've now got our list sorting, so we get nodes connecting to nodes, or lines connected to the nodes that we define. And now we just need to feed them with another, the proper list. And that proper list is not the bottom list this time, but the top list. So I'm going to feed the top list in. And now we have our definition of our top chords. So let's just take a look at what we've got now. So now each one of these, now you'll see these are straight elements. They're no longer curved, which is how a truss has to be to perform properly. And we have all of our single defined bottom elements. The only thing left to do to define our truss system is to put our diagonals in, and we'll pick that up on the next clip.